Hello, my name is Jiri Pipek, I'm system engineer from Trask, and today I would like to introduce you Zilla, which is API gateway for Kafka. Zilla is a multi-protocol proxy that allows you to access Kafka via several different protocols, such as REST, server-sent events, MQTT, gRPC, or even WebSockets. These protocols thus allow a number of clients to connect to Kafka that do not have native libraries to communicate with it or want to communicate through their native APIs. Examples of these include microservices, mobile and front-end applications, IoT devices, and many other clients. In the pictures we can see the advantage Zilla brings. If we look at the picture of what the integration looks like in most cases now, there are other components that come into the picture, such as connectors in Kafka Connect, Confluent REST Proxy, or other technologies. If we use Zilla, all these dependencies are eliminated, because instead of them we built a single open source service, which does not require any external dependencies and is perfectly ready to run in a containerized environment. For the video, I have prepared a sample of two real examples that can be solved with the tool, so let's take a look. The first example, where we started to consider using Zilla, was the communicating of existing React front-end applications or their individual instances via MQTT and WebSocket with their backend. The reason for using Zilla was the possibility of dynamically horizontally scalable backend that handles these requests from the frontend, and Kafka and its partitioning mechanism is ideal for this. When we look at the diagram itself, it starts with individual React application instances that have their own sessions, after which they need to communicate with the backend. React apps use Zilla to do this, which passes their MQTT topic with requests to a Kafka topic, from which the backend apps can read it, process it, and send it back to MQTT reply topic based on the session information, from which the frontend app again retrieves the reply. Now let's see how this can be implemented. As seen in the diagram, the example contains the main three components: React application, Kafka cluster and Zilla, and then a simple backend. Let's start with Zilla and its configuration. Zilla can be configured using this YAML file, using definitions of individual protocols, ports, and routing. Then I have a simple component in React that communicates via WebSocket to the MQTT broker or Zilla, and at the same time receives replies from the reply topic from MQTT. The last one is a simple backend that simulates backend workers. It only reads messages from Kafka and then returns them back under the correct session ID to the MQTT topic for the corresponding React application. In AKHQ we can see the topics that Zilla uses as a storage for MQTT messages. These are the two topics where Zilla writes requests and response for React applications. Where Zilla should route these MQTT topics within Kafka is specified in the Zilla configuration file. Now, on the left, we have one of the React application instances that has its own session ID, and on the right, we have a running backend that is ready to handle front-end requests. When we send a request now, it gets to the backend via WebSocket, MQTT, and Kafka. It processes the message and returns the response to the frontend of the application via MQTT and then WebSocket. If we look at the second instance of the application in a new window with a different session ID, of course, no response is received because the messages are routed thanks to the session ID only where the request was made. If we look at how Zilla stores this internally in Kafka, we can see the following. All requests from frontend instances are routed to the request topic, where the Kafka message has the form that the key equals the name of the MQTT topic and the body equals the value of the MQTT topic. This makes it possible to have several MQTT topics in one Kafka topic. The request topic is then connected to the backend, which is here represented by a consumer group of devices that read and process the messages using a normal Kafka consumer. Reply topic is in Kafka mainly because of Zilla's internal implementation. However, in our case, React applications consume messages directly via MQTT and MQTT protocol, not via Kafka topic. The goal was to enable dynamic horizontal scaling of the backend. So let's scale the backend to 3 workers and see how the partitioning allows different instances of applications with different session IDs to be handled by different workers. The second example I have prepared is the use of Kafka REST proxy. It is a relatively simple scheme. The architecture is designed to manage codebooks via Kafka, where the component produces codebooks into a compact topic. But now to the problem. Most applications can connect directly to Kafka and read the codebooks. But what if we have an application that does not know Kafka or needs to consume only the content of the codebooks? For this, we can use Zilla again and expose a REST interface about the topic of codebooks, which will allow access to the data. Zilla catches the message from the topic in the background, so the querying is quite fast and can be used in this use case. Apart from the read operation, Zilla offers all other operations such as create, update, and delete within the compact topic. Now let's go to the demonstration itself. To begin with, let's take another look at the Zilla configuration file, where we can see the defined REST APIs for a specific topic. I have prepared all available operations for the demonstration. However, if we want read-only, we can simply remove the rest of the operations. I have prepared a topic in Kafka that contains several codebooks, as you can see. Always the name of the codebook equals the key, and in the body there are individual codebook items. Now we can call the individual APIs directly in Postman. First we can call the list of all codebooks and we can see that the answer is the codebooks as we saw them in Kafka. Then we can send a query only to specific codebook according to its key in Kafka. We do this with the following call. And here is the result. Now we can try some more operations. Let's start with the update, where we can see how the changed codebook is written to Kafka under the same ID. In the same way we can delete the codebook, i.e. send a tombstone message to Kafka. Last we can show the create operation, where we need to send idempotency key as a header, which Zilla internally translates as a message key to Kafka and uses it as a unique identifier in the compact topic. So that's it for the examples. Now I'd like to conclude with a few pluses and minuses that I subjectively found in this service. Among the pluses is clearly that it has no dependent technologies. It is simply one container, one service. Thanks to this, it is also ready for automatic scaling in Kubernetes. Other pluses are the constant development of new connectors and support for integration with Prometheus. Among the minuses, I would include mainly the fact that it does not support schema registries, which can be a problem in some cases, especially if the whole architecture relies on topics with schemas, but even this can be solved somehow. Next, the documentation for Zilla is nice, but sometimes there is some information missing, or even thanks to the smaller community, it's not quite easy to debug things. And lastly, for its production operations, you need Kubernetes or OpenShift cluster. That was all from me in this video. I hope you enjoyed Zilla. Thanks for your attention and have a nice day.